kind of getting started again. This is KnoxData. We're a data science group based here in Knoxville. We're doing our first ever virtual meetup. So thanks again for everybody for coming to join us to do this. Our group's been around for 5 years. We just did our 5th anniversary in February. And anyways, we've kind of been all over the map. Now we're getting to fill back in some R content we've been missing for a little while. So we're really excited about that. Just want to have 2 other things to talk about. So we have our Meetup page. So again, meetup.com/KnoxData. You can find all of our upcoming events. You can also find our past events and kind of see some of the flavor of what we've crossed over in the past. On our GitHub page on KnoxData, we have a listing of all like what the talks were about, who gave the talk, and kind of a re-summary of what the things were. We try to add to that as we go. Finally, here in Knoxville, we have a large consortium group called KnoxDevs. It's a nonprofit and basically helps all the different software developer communities here in Knoxville. So I'm also part organizer of that, and we do a quarterly event about every 3 months to kind of bring people out. So anyways, it's great. So if you get a chance, visit the website, knoxdev.com. You can see all the different other groups that we have in Knoxville. And the biggest thing is that we also have a Slack channel for us. And so you can kind of get a chance to join the Slack. And then there, you can also see some of our calendar events. Obviously, we've canceled a lot of things in person, but we'll have more stuff here in the next couple of months back in person with all the different groups. But otherwise, without that, I'm going to stop share. And Brian, you can take the wheel. First, if you don't mind, introduce yourself a little bit and go ahead and get started.
Great. So thanks for inviting me. This is great. It's great to have this group. I'm Brian O'Mara. I'm a professor at UT, Knoxville. I work on phylogenetic methods. So I work on basically understanding evolution by building phylogenies. If you've seen, the phylogenies of coronavirus and things like that, I work on methods to help build those, to help use those to understand evolutionary history. Most of my work now is in R. I've also worked in, PHP for some website stuff, C++, various, JavaScript for things like that, but mostly R. Haven't done much Python yet. And so you can check out my website. You can check out my GitHub. One thing to note is that we have a chat in the Zoom. And so in the chat is a URL for today's materials. Can everyone see that? Yep. Okay. Cool. So as we have questions, please feel free to chime in. With Zoom and stuff like that, oftentimes what's useful is social mumbling. So when you want to start talking, you say, so, and then we all stop and listen to what you're actually going to say. If you launch into your question right away, it won't work. So please don't worry about interrupting. That's great. If you are worried about interrupting, you can use the chat and someone else will interrupt or I'll see it. So it's all loose. It's okay. Let me start sharing my screen. So can all see the website? Yep.
Yes.
So what we're going to talk about today is using Drake. So Drake is a way of, it is modeled on the idea of make. So those of you who've done C or C++ or things like that, when you have a make file, when you're compiling something, it takes a long time to compile it. And if you modify one part of code, you also want to recompile that one part of code. And so make files and make can do that sensibly. And so it saves you from redoing things over and over again. And Drake is a way of doing that as well. And it works in R. And so what I understand from this talk today is the utility of workflows, how and why to use Drake, R Markdown, and parametric R Markdown. We'll just show through some examples. These can save time. So if you're doing something like you want to do a report on your company for every quarter or something, parametric R Markdown, you can have it automatically create all of those, right? We use those in my department for doing reports on every student every year, so we can keep track of how students are working, identify any people having problems, and so we can use R Markdown to help keep track of that too. Okay, so why Drake? So one idea is reproducibility, right? So we had a paper published recently responding to another paper, and for that we had this GitHub repo where we have all our work in this one repo. We can have this part of the paper, and anyone can go in and look to see what we did. So we have our plan of analyses, and then can go through and check our analyses and check our results. we'll get through what all this means later, but this is sort of an overview that lets people go through and say, oh, I think you messed up here, let's fix it this way, and they can check it. It's all very public. It's useful for scalability. So for my department, we recently had our 10-year review, and part of that is comparing your department to other departments around the world. And the issue with that is there aren't really many good comparisons. So what we did was we had a student, Andrew Wittes, work with me to go gather 10,000 Google Scholar IDs from faculty of other competing departments or comparable departments. And then we ran a workflow here to go through and compare our department versus other departments. And so went through Google and scraped 1,000 records of faculty scholar information, so how many publications they've had, where they were published, how many citations they've had, and pull all information in using Drake. And so basically looping over once for each faculty member, and then saving them all, and then bringing them all into one file together and analyzing them. And so that's something where it was nice because we could scale it. And with Drake, if we have to stop partway through because Google blocks you or your internet connection goes down, you can pick it up again from the same point. So you don't have to restart everything, which is wonderful. And then if we want to like tweak something, so we were doing some plots and had to fix a plot, I can just change one line of code, and all it will do is change the plotting code and leave everything else as it was, and not to rerun everything. And so it's been really flexible that way. And so Drake's one of those things that, like Markdown itself, seems sort of silly and trivial at first, but once you get the feel of it, it's actually, wow, this is really useful. So that's what I'm trying to get through today. Why are Markdown? So Markdown is, so who's here has heard of Markdown in the chat? Yeah. Most of you? Okay. So Markdown is, basic, simple, it's an alternative to HTML, still wraps for HTML. And there's an R version of it where you can actually include R code within it. Now people also include Python code within it. You can make these nice reports, and you can do things like, for example, this website I'm showing you now was made with R Markdown. My own personal website is made with R Markdown. I have a book I'm writing that's in public that's made with R Markdown. You can make blog posts with R Markdown, PDFs. It's really handy to generate things like that. One nice thing about Drake also is the whole free book about it, right? So if you go here, the whole book that has videos, has a history of it, has how to create it all, and that's really helped me write this description here. And one thing to note is I'm a Drake enthusiast, not a Drake author, right? So like I do write R packages and things like that, and I love my own R packages, but Drake just makes my life so much easier. It's like, wow, so I'm just becoming an evangelist for it. That also means though I might not be using it perfectly correctly, right? So I have things that how I use it, but I'm sure the developer will be like, oh no, you have to use this other thing instead. So, it's shows you how me as a user in this case uses it, but you can develop your own techniques for how you work with it. All right, so let's start with how we do things without Drake, right? So we have, this sort of R file, right? Can people see this? Is this font big enough? Okay, great. Yep. So you call in your libraries you need. In my case, tidyverse and cowplot for doing some ggplot stuff. Pull in a data set. So here I was looking for a recent data set. So I pulled in flight information for all airports in the US for December. It's the most recent one available. And so it has, I don't know, tens of thousands of records. So I pulled that data in, cleaned up some of the data, care about Tyson McGee, that's our local one. Run through, the outbound flights, inbound flights, basic function to make plots, right? Basic functions to get other information out, and so forth, right? And so I can go to R. So I can do pull my script, run that script, and you can see it's reading through, loading the packages, loaded my tidyverse. Now it's pulling in my giant CSV file. And now it's bringing up plots, which you can see. And so I can just scroll through the plots, right? And get information about, at Tyson McGee, what causes delays? Is it, the carrier causing delay, the weather causing delay, air traffic control causing delay, security, I can see how flights have changed over time. So not a lot of flights on Christmas, right? You can see flights by day of the week. So Saturday and Sunday is lots of flights. Friday, not many flights at Tyson, right? And so it's all very cool and all, you know, the beauty of R and things like that, right? The problem with this is if I want to go back here, so here's my basic script here. If I want to do something like change the color of something, right? So let me change the color here, save that, right? Rerun, does everything all over again, right? And because it's a pretty simple script, okay, it takes another 30 seconds, we can survive that, right? We start doing large scale analyses, it becomes a lot slower. And so what we'll start doing is things like, you know, going through and only doing, okay, let's see, I can skip this part. I just call these lines, I'll copy these lines and copy these lines in my terminal or whatever, which makes it really unstable and cause lots of issues. It's no longer reproducible, right? What if it depends on you calling line 17 and then line 3? And so it's just not a good way of doing science. And so I see when teaching grad students, a lot of them sort of start off this way, right? And sort of tweaking. Now with Drake, we can do something different. So let me go back to Firefox. So we have an example here of, these are all linked to on GitHub and stuff, so you can see everything, right? And here is our basic structure of our Drake file. So we have an R folder that has functions, packages, and plan, which you get to, and a make file, which is super simple. And so I'll just show you this in Atom. Okay, so again, we have R and we have make. And basically what I've done is take this script and broken it up, right? So what libraries do I need? I put those into the packages. So tidyverse, cowplot, and Drake. I'm just keeping everything organized. And this is the way the Drake developers suggest that you organize things. So I just have one file that has those, right? I have one file that has my functions, okay? And so the functions I have from here, you know, making a histogram, things like that, or, you know, pulling my flight data. So loading my files, I just made that into a function. All right, does that make sense to folks? Any questions yet? Okay. Yeah, one thing we learned about teaching is like wait time matters. And it's like a 10-second pause feels like forever, but for teaching, it's actually useful. And so, yeah. Right. So this is. Go ahead.
Sorry, am I correct that you don't have to write everything in functions, that you can just write normal scripts?
You can, yeah. Functions are handier because it makes your plan later a little simpler to run. And one nice thing also with Drake is you can look at dependencies with come from functions. And so I'll show you how that works. But you don't have to use functions. And actually this example here, I think I don't have functions for one of the lines. Yeah, good question. Turns out to be, it is generally easier though to have it as functions, I find. So I have a function for getting flights. I have a function for getting this plot, you know, function for getting this plot, function for getting this plot, right? So basically 5 functions, okay? And then I have a plan. And here's the heart of Drake. Basically the plan, this is a function call, a Drake plan. And then I have basically, it's creating effectively a data frame. So if you're familiar with R, data frame is basically R's sort of matrix, where you can have different kinds of data in every column. And so every column has a name. So here we have a column called focal flights, and it has this argument, this entry, plot delays, this entry, and so forth. And they're comma separated. So one easy mistake to make when you're first learning Drake is forget these commas, because you usually don't have commas at the end of lines. And so basically what happens is get focal flights, this function, just gives me, this loads in all my flight data, filters it in various ways for Tyson McGee, returns that to me, and then that is stored here.
After he sold the stock, he went.
And then that's then used by the plot delays function, right? And all that does is do a grid plot of all the things that cause delays. right? But the key thing about Drake is it knows that since plot delays has this as an argument, this won't run until this is created. And if this changes for some reason, it will rerun this. But if that hasn't changed, it won't have to rerun that. And so that makes it a lot faster. And same thing for the other plots. Okay, and that's it. Basically, that's the core of it. And then the make file is just sourcing in the art packages, sourcing in functions, sourcing in plan, and then making your plan. Okay, so let me show you that running. So here we are. This is all targets already up to date, so I already made them, right? So what I can do is just, I can clean them. So like, you know, make clean if you're compiling a C package or something. So now we'll have to rerun everything. And so it's now loading in that data, that CSV file again, which takes a while. Now I have my plots again. And I'm not storing them, I'm just having them display in a quartz window. But of course, you can make them saved as a PDF or something like that. That'd be better, right? And here we can cycle through the plots again, and same idea, right? Now, one thing Drake can also do is show us the plan. And creates this interactive dependency graph. And so we can see, you know, the function, you know, reader is used to get the focal flights, load that, and that object goes into these other, is regarded these other three objects. And also, since I've already run the plan once, Drake shows me how long each element took to run. Right? And so we can see then how everything relates to each other.
Brian, I'm so sorry to.
No, please, please.
How do the up-to-date elements differ from the triangles here? The imported, is it imported functions? Those are functions?
So these are the functions they're used, right? The functions are triangles, and then the objects made are the circles.
Oh, okay, and that's how long it took to create that particular output or that object.
Yep, so if you think about it as that line in the plan, right? This line took 10 seconds to run. You know, this line took 1.7 seconds, 0.6 seconds, so forth.
Okay.
Yep.
Thanks. Got it.
You're welcome. Yeah, good question. And so for more complex workflows, you can see, you know, this can be a helpful thing to look at, right? And actually, for one of the things I was working on here, well, I had one thing that wasn't as a dependency, it was independent of everything else, and that showed me like, oh, it's not connected to anything else, it might not run properly, and so I had to make a dependency. Okay, and so you can see that those you know, basic steps, that's not much harder than writing your R function, right? So comparing this to the Drake thing, you know, it's split up into functions, into the 3 different files, which you don't have to do, but it's handy. And then the main difference is having this plan, right? Now, one thing that's handy is once this is done, I can still load things in. So my workspace has my functions, right, in my plan, but not these objects that are made, right? So we want to look at what that is, I have to load that back in. So with Drake, it's 2Ds for things like load, focal flights. And now I have focal flights back in my workspace, and I can look at the beginning of focal flights. See, okay, it has day of the week, has, you know, basically 41 columns, and the head just showing 6 rows. Right, so if I want to do something else with it and play with it, I can, or can do things within Drake.
Hey Brian, can you move your screen up a little bit, because I'm
Oh, sure.
seeing the bottom of your screen.
Better? Yeah. So again, just to show what I did. So I loaded with 2Ds. So basically any object that is created by one of these calls, you can load that back into Drake. So by default, it's not in the memory afterwards. You can load that back in and then play with it. And now the advantage of Drake is if I do now want to change something, like, let's say change the color here again, save that, and now I do this, all it's redoing is that one plot, right? And so everything else doesn't depend on that change, and so I don't have to reload things again. So it's much faster. And so over here, I've saved 10 seconds, right? But for real life, on a large, say, simulated analysis, like we do in our lab, it could save you months of work and have to redo things. So any questions about the basic example?
Brian, does this apply to different sessions of R?
Yep. So if I quit, right, and then start again, if I do all targets already up to date. And so how Drake actually works, it caches these things in a hidden .drake file, or .drake folder. And so if we look at that, you can see, it has subfolders as well. And basically all the things it's made as it goes.
Wow.
And so those can get big, and so that's why cleaning can get rid of those. There's a big sort of undo though, but yeah. And so like for GitHub, you make sure to exclude those if you don't want to add those to GitHub. But that's what keeps track of what it's done in the past.
Awesome, awesome.
Yeah. Cool. Okay, so that's the simple approach. So again, just basic idea of, you have your packages, your functions, your plan. Your plan just has each of the element. One other trick is it's equals, not the typical R, arrow thing. And so that actually matters here, unlike most of our, that's the main difference. And so that's how you plan, and then you have this make, which is called make plan, and then you just run it. So what I also want to show you is a more complex example. And here, we do the same thing, packages, functions, plan. And our plan is slightly more complex. So again, we're getting all our flights, right? I'm just picking out some of the airports. So what basically my idea here is, rather than just doing it on Tyson McGee, do it on all the airports in the US that have at least 3,000 flights, right? And so we'll make those plots for each of those airports. And rather than having it as a, just a bunch of graphs flickering by on the screen, we'll store them into a website, into a web page. This is all stuff I made in the last 2 days, so this is very easy to iterate on. And so basically the way to do that is I have a template in our Markdown, right? So we have, those are something with YAML, a YAML header, okay, like you see normally in our Markdown. You have an output, but also you have params. And so when you knit this, when you convert it from our Markdown to an output format like HTML or PDF, you could include these arguments, and the R script can actually use those arguments. And so basically you can call this over and over again, calling it TYS, ATL, BOS, and so forth, and cycle through those, and it will create a new R Markdown output object each time. Right? And so for example here, I have, basically I'm getting the focal flights, right? So the flights that I'm interested in, just leaving from or going to this particular airport. Right? So this function now filters through and only gets flights that are going into or out of Tyson McGee, for example. Okay. Then I include here, so one nice thing about our Markdown, it has like, this will give you an H2 header, this will give you an H3 header, those are your regular used to HTML. So it converts nicely into HTML, or you can do bolding or italic, things like that. If you want to include R code inline, you can do it with this backtick R and then the function or just the object name. So here what will happen is this will spit out, TYS. And so when you see the final object, it'll just say this shows the December 2009 performance for TYS airport or ATL, whatever you put in there. Then I just do my regular, plotting, my 3 functions. Okay. Any questions on that? All right. And so there my plan, just slightly more complex since I have, I'm pulling out this list of airports, so I'll show you that function, right? So get important airports. So I take all the flights, I say I only want airports that have at least 3,000, not more than 100,000 flights, which is nothing in this data set. You know, all the flights, right? Do a subset for my, find all the airports that matter. Sort those, get a list of them, and then export that list of names, so that list of 3-letter codes. That's all that function does. So out of this, I have a vector of ATL, ACE, QIS, etc. Okay, so that's what this is getting me. I can get the URLs from, so then I have to have this. This is the key line here, right? So I have a make parametric report argument. Let's show what that, a function. Let's show what that does. Right, and this just takes in your focal airport, so your 3-letter code, TYS, etc. It's going to create an output string that is airport underscore that 3-letter code .html. Right, and then I have this rmarkdown command call, so rmarkdown render. And what this does is takes in our rmarkdown file, so this thing we're looking at over here. Sorry. I'm going to convert it into an output file, which is this format. So since I have .html, create an HTML file. If I had a PDF, it would make a PDF. A Word doc, it would make it Word, and so forth. Kind of cool. One other unique thing about Drake is when you're doing output file, it often has you wrap it in this file out or input file in function. That just tells it to go look for that file as one of the outputs. It helps it keep track of which files it needs to keep track of. And then here I'm passing in my parameter, right? So if you want to do this without Drake, just using regular rmarkdown, you could. You just use the same function call. So if I were doing something where I wanted to just loop over this manually outside of Drake, I could do that and just pass in focal airport equals TYS, focal airport equals BOS, focal airport equals ACE, and each time you create a new rmarkdown output file, so an HTML file in this case, with information for that airport. And you can pass in more than one parameter. So you want to do it over, you know, airport by month or something like that. So you can have each airport each month being a separate file. That'd be great. And so the nice thing about this is it creates this custom page or document for every single argument you pass in, which can make things very flexible, right? So you want to, if you have to do, you know, Oak Ridge research output every month, you can just pass in a list of months and it can output these very naturally. Or something over across different faculty, but outputs these very naturally. So that's this parametric rmarkdown. Okay. And so any questions about that aspect? Okay, back to our plan. So one nice thing about doing it with Drake is I can do it so that, I can basically run across each of my important airports. Remember, is this vector of, you know, all these different letters, and I pass this in here. And rather than doing it, you know, for all those at once, it loops over this. It does this one at a time as it runs. And there's actually ways to make it so Drake will run in parallel. So if you have access to a compute cluster and you want to use Future or cluster MQ, it can run that in parallel across your cluster. If you have a multi-core computer, it can run across that easily. And so this is a nice way of speeding things up. And then if if your computer dies halfway through and you rerun this whole thing again, the ones that are finished, it will keep going from there on. So we'll keep track of which ones have completed, right? And what I've done here is I have it, after it does that command, it tells me which ones sort of worked. And those working ones, I keep track of those and basically get those letters back again, right? TYS, BOS, and then pass those into this other command, again, running in parallel with Drake or sequential with Drake, where I do a summarize for every airport. And that's just a function here. It just tells me for every airport, it's, you know, the URL for that web page, the location based on the information in the downloaded data, how many flights outbound, how many flights inbound, departure delays, arrival delays, and so forth. That just gives me a data frame. And the nice thing about this plan is when it gives me this, it then compiles them all into one multi-row data frame, right? So I have one row for every airport, so nice and tidy. And then that goes into another R Markdown document, right? So again here, right? And here the parameters is the summary information. And this is very simple, right? All I'm doing is taking that summary information and taking out, sticking it here, which is redundant, you don't need to do that. And then just making a table of my R Markdown. And that then goes new object, so airport overview.html. And then I render my site, right? And what I'm doing here, this shows how the utility of passing in functions and things. So the render site command runs every time this changes and or this changes, right? And if you look at the regular render site function on here, it actually doesn't use those, right? So summary is not used anywhere here. Summary is not used anywhere in here. It just calls this function that uses R Markdown to create an entire website. And so when that happens, so but this way it remakes the website every time anything changes further up. Okay. And so if you go back to here, so this website is made by that function. That very complex idea. So just showing that function, the files you already saw. And here's the result. So this right here, the airport I'll go back to it. This airport overview.rmd becomes this airport overview.html file, right? And here's the table we made, right? That has information about each airport, its location, outbound flights, inbound flights, median delays, mean delays, for both departure and arrival. So it's kind of cool. You can see, okay, you know, Atlanta is a very busy airport, but delays aren't that huge on average, right? Now, if you look at maximum delay, it's horrible. But also, since the earlier Drake command, you know, create a new website for every single one, right? A web page, we can actually go and look at those web pages. So this is also created as part of that analysis. So we can go through, and so for every airport that has at least 3,000 flights, we now have for December plots of how the flights have changed over time. Right, and so Nashville, whatever. And so you can see how powerful this approach is, right? Where, you know, doing this manually or having to type in, like, okay, now we do the Atlanta one, now we do the Boston one. But by doing with this nice little loop in Drake, it works very fast, and then you can update things and doesn't have to redo everything at once. So that's the main parts of that.
Brian, just a kind of foundational question here. This plan, the plan here is considerably more complex than the first example where we had like four lines in it. One challenge for me as this gets more complex is like knowing here what is a Drake function and what is either an imported function or a function that is in the functions.r file.
Yep.
The target function in specific, that's a Drake function, right?
That is a Drake function, yeah.
Can you remind me what that does?
Sure, that tells it, let me just pull up the documentation first, it'll be easier. And note the caveat here, maturing, right? So this has changed since January, and so they're continuing to update this. And this just tells like a thing is going to build, right? So the thing's going to run. So in my case, is running this function, right? With these inputs, right? But where it's using, it's pasting in one at a time, you know, the elements of this as this when it runs this function. So it's telling it basically do this as a loop. It's almost like similar feel to like apply or apply in R.
Yeah, sure. Yeah.
Yeah. And so you can map. So one thing you can do rather than, so with cross, you can also do if I have multiple arguments. If I have, you know, if I had something like working airports, you know, day of week. And this as day of week. It would do all the cross product of these would give you, you know, every possible airport with every possible day of week.
Oh,
right,
wow.
so like the expand grid sort of approach in R. And that would be that approach with that. I can also do a map. So if you're into tidy stuff and a gritter, you can do this map where you split things up in different chunks, right? So I could chunk it that way and passing each chunk directly. And this is using something called dynamic splitting, right? So what I'm doing here is rather than using, a single, like do this 5 times, I'm just saying, take however long this working airports is and do it once for every one of those, right? But Drake does let you do a static branching, right? So, rather than doing something like this, which looks horrifying, right? You can just say, I want to do it for fast and slow and mean value 1 to 4, right? And model function, the set of model functions. And that generates this basic thing, right? But much more naturally. And so for some of the stuff I do where you have like simulations where you're going to replicate it 10 times, doing it this way could be handy, right? And that's called static branching, right? The nice thing about this is then you see the plan and you can see, here's the output from that viz Drake plan function for that thing, where you can see it hit the data. I have 2 summaries and it shows me different things I'm running in parallel for that, right? Whereas with my dynamic plan, when it shows the plan, it doesn't know what it's going to do because it doesn't know the variables yet. And so it can't show that, it just shows this node where we go through. We don't know how many things are going through that node.
Cool. This is helpful.
Yeah.
So it's sort of like a wrapper. Target is sort of like a wrapper for kind of plan level iteration or repetition.
Yep. It has to be used within a plan function call.
Cool.
Yep. So it has to be used inside here somewhere. And you can see I have 2 different targets in the same thing. And since this one depends on working airports, and working airports depends on URLs, this one has to run after this one. Right, and so Drake knows that automatically, which is nice.
Thanks.
Yep. Good. Other questions. So you can see, I'm just using Google's GitHub sites for this. And so this docs folder is where everything's being copied over to, right? And so these are all the .html things except for were generated with our Markdown. It also takes my R Markdown for like this basic site I was showing you and creates this index HTML. And the only weird thing you have to worry about with doing this is this site YAML, right? Which has things like our menu up here, right? Comes from this, right? And also some things about like which theme you want to use and so forth. Right, but it's all just done otherwise with just R, such as a render site call.
So just to be sure, this is not using like Jekyll or Hugo or anything else other than R Markdown?
Yep. I'm not sure where the flatly is coming from. So that's a theme from somewhere, not from R Markdown. But I don't have to install Hugo or Jekyll to make this run. It just runs automatically. It does use a site libs. And so it's just, jQuery, things like that. But yeah, other than like, it's like, this is a lighter weight thing. I mean, there is a way to do your Jekyll and Hugo and things like people do that with R now. But I find this is a lot simpler to use. You don't have to worry about, versioning and things like that. It just works automatically and creates this nice, just basic HTML files, right? With the figures sort of encoded inside.
Thanks. Yeah, it looks great. I remember reading in one of Yihue Shi's books, the R Markdown, one of the main developers, talking about creating websites this way. And he sort of talked about it as sort of like, oh, there's this option too, but you can use Jekyll or Hugo, whatever. I didn't realize how great this looks and how, yeah, I like the aesthetic of the site as well as how it's pretty straight a way to create.
Yep, and you can add headers. So my main website, I have a Google Analytics tracker in there, so I can see how many people hit my site, things like that. So those are the main points of this. What other questions do folks have about this? So just to review what we've gone over a little bit, it's been a lot, right? So using workflows, idea of like this workflow being helpful, right? And both for speed and for reproducibility. The idea of R Markdown to create these documents, and then parametric R Markdown to be able to use the same R Markdown template to make multiple documents. Right. And we get also then a bit of making websites from this too.
So Brian, when you get started in a project, do you just start in an R script, or how do you get started in this on a particular
project? For me,
project?
lately, I'll make an R script that has my functions. So I'll basically do this Drake simple thing. Where I just have my basic, I'll start writing functions as I go, right? I'll keep track of which packages I need, and then I'll make my plan as I go. And that's for if I'm doing an analysis, right? If I'm running a package, it's different, but for analysis, I'll do that. That's this sort of approach.
Yeah, thanks.
Other questions about this?
Brian, just this, you may have gone through this, but so do we just load Drake as a normal R package at the beginning in the package?
Yep. So when you're doing, so here's the simple one, right? Mm-hmm. So all I do is I just open a bare R session and I source make.r, or I can do R script make.r, right? But then one of the packages in here is Drake.
Gotcha.
Cool. Brian, I have two related questions about how this is different from other similar techniques, not even packages. One is something like Docker, which I've read about and tried to get started on, and to confess, didn't get very far on, and so didn't ever use it. The second is something like caching in R Markdown, which I've struggled with even when I've named the chunks. Oftentimes, well, I've just struggled with it over many projects. And so how does this, how would you say how this compares to those two things?
So let's start with the caching first. So when we have an R Markdown document like this, right, we can add a cache equals true argument to some of the R blocks, right? And what that tells R is if this hasn't changed, if the things going into this haven't changed, don't mess with it. And so if you're doing a long run, this will save time. We can rerun it, it'll still be cached. I'm not sure how aware caching is of previous steps and dependencies, whereas with Drake, it's much richer and it does that better. Caching won't track times. And so, sometimes I found like responding to reviewers, like I could do this, but it'll take me another 70,000 computer years, which would cost me this much money. So, right, reviewing a paper, replying to reviewers. Caching also is just an R Markdown thing where Drake is for everything, right? So you don't have to use R Markdown with Drake. So if I'm doing something where my outputs are data frames or CSV files, R Markdown, you could have a cache within it and have the R Markdown create the cache, but also just go directly with Drake, right? And not have to go through the R Markdown intermediary.
Got it.
There might be other differences. I mean, with Drake's cache, actually you can roll back a little bit. It's a newish feature where like if you erase your cache, you can go back to an earlier version. Kind of cool. Cool. That's new, and I haven't played with that at all yet. So yeah, but I mean, for a quick lightweight thing, I mean, going with R Markdown and caching can be really handy. Drake also gives you I mean, with R Markdown, I've also seen files where it becomes like basically a mess again, so something like this, right? But you could have it with all this inside an R block, right? And then, or like several R blocks and still sort of messy, how to figure out the flow, right? But Drake sort of encourages natural thinking about flow, right? So this depends on this, depends on this. And you actually visualize it too with the visualization thing. But yeah, I mean, this is, there's nothing wrong with doing R Markdown caching. It's just Drake's a little more advanced and more, And then with Docker, I mean, Docker, you can see Docker here. Docker creates, it's not really fair to call it a virtual machine, but it has the same feel of that, right? So with the deal with Docker container, you spin up a machine when you need it, and then you throw it away when you don't. And you have any local files you need to sort of save locally. And basically you can start, the idea, it's rather than using like VMware or those older things, it's nice because it's running on the same basic operating system underneath. And so it's a lot more lightweight. And so you have lots of these Docker instances running in parallel on your computer, and my laptop can handle many of them. And the nice thing about that though is you can have different, you have things like this requires PHP, this requires Python 2, this requires Python 3. They can all run on separate basically little computers and have all the dependencies they need, and each one's independent, and just pass information back and forth as as basically independent computers on a website, right? And so it can be handy to spin things up and shut them down. So like for like my kids' Minecraft servers, for example, I have a different Docker instance for each one. So we spin up one to have like, this is Minecraft 1.14, this is Minecraft 1.13, and it's good for that. Bioinformatics will use it for if you have something that has weird dependencies, right? And some like DNA alignment software that requires some odd thing. You can have that call up. And one other thing you can do with that also is you can have other things call into that through a command line. And so there's ways to, from your command line, even from an R script, spin up a Docker instance, get information back out, and pull it back down. So we're doing analysis. We're looking at continental plate motion over time. And there's a service called gplates. Put up here. Let's go here. So it has these reconstructions of plate tectonics through time, and it's great. But the website was down, and so we could do those. We could run a Docker instance that basically replicated the website, which they provide. We didn't provide that. But have an R script that could actually call that and get back what the place looked like in Jurassic and get a plot of that. And that way you can just call that as basically a command line call to this separate computer running inside your own computer. And so it's a lot more featureful, but it's a lot bigger lifting than Drake or Markdown, but also much more general, right? So you can run a Python script within Docker. And right now it's being sort of eaten by, Kubernetes is something that sort of runs multiple containers and works them across computers, and that can run Docker or Singularity or other things. And so it's a rapidly evolving space.
Cool, thanks. That's super helpful. The tacit part of my question was, I see a great need for something like Drake in my work. I can't tell you how many times I come back to something 6 months later, and 3 months before, somewhere in between that 6 months, I made some change, and now the script doesn't work, and I have to spend a day debugging it, and it's extremely frustrating, even when I have version control, even when I'm using version control. This seems super helpful.
Yeah, I heard someone say, like, my most common collaborator is me in the past and never replies to emails. Right? So, yeah.
Ross says this is not directly related, but has anyone used the vroom package to load CSV files in R?
I haven't.
I have not either.
I've used it. It's really good.
Yeah, it's really good. I think it's faster than most of the packages that are out there. So I noticed that you're using Reader for that.
Yep.
I was loading a CSV file that maybe is, I don't know, maybe 10 megabytes or something, and it goes in just a few seconds, like really quick.
That's really cool.
So it's worth trying. And
yeah, it's called Vroom, you said?
Yeah, and I can send a link to the chat box. It's a Tidyverse package actually, but it's not integrated in Tidyverse yet. So you have to call library Vroom separately, but it works really good for loading CSV files.
Cool.
Cool, thanks.
That's great. And also you see, in my, the scripts I showed you, I'm doing subsetting and things like that. So I'm not super cool. I'm not using Regritter. I'm not using Tidy all the way. I'm not using data table, which is a giant file is what you should be doing. So, the stuff like, so, look through my scripts and like get, pick some useful stuff out of it, but it's not like the best way to do everything. I'm still learning too.
I'll defer to others with questions. I have another one, but I'd love to let others have a chance to ask.
actually one other way of doing this besides the whole Drake and stuff, I mean, is for data analysis is making it an R package itself, right? So if I'm doing an analysis, one approach people are using now is to make an actual R package where your functions become functions in the package. And the nice thing about that is it encourages you to have nice documentation for the functions, right? The downside is you often can't include the data if it's going to be a large amount of data because CRAN doesn't like data.
So kind of piggybacking on that, Brian, how do you share the results of this? So obviously it's useful to you and collaborators. Do you ever do anything like point to a repository from a finished research project or in a publication associated with it and say, here's sort of the analysis in this format where you can run sort of that make function, the plan function.
Yep.
That's right. The plan function, and you can sort of reproduce what we did. Do you do things like that?
Yes, I mean, yeah, so like that thing I showed you with, this return of the minivan thing, this is from published paper. And so we included, we also published our, our package, our Drake workflow and everything, publicly available on GitHub. I'm not sure if we put this in Dryad yet. We should. That's better practice to put it in Dryad, which is our sort of repository for data and R scripts in my field. But this is data for this, and so you can, basically what we're doing was pulling information from different articles and shows you how to run it, right? And so people who read this is a response to another paper, so people who read this can go through and run this and compare their results with our results and say, oh, you forgot this thing. Let me try using this on elephants instead of plants or whatever, and use the code that way. But the main outputs are still like if there'll be figures for a paper or a table for a paper, or things like that. And so those outputs are the same. You can just do a file out, myfig.jpg, right? And then use that in your Word doc or wherever you're submitting your paper. So that part's not typically different. Yeah.
That's helpful. Thanks.
Yeah.
Hey, Brian, I have one question. So I really love the dependency graph and showing the timing of everything. Do you have my chance to know what's in the background, what Drake is using to put that together?
I don't. It looks like a sort of JavaScript thing.
Sure.
But
that seems really cool. Are you able to, let's say you are when you are publishing, this for your main text for your journal, blah blah, and you're adding this as a supplementary feature.
mm-hmm.
Is there a way that you can basically place this dependency graph within your R Markdown document to kind of show what that timing was for some of your analysis?
I don't know. I mean, there is also a way of getting it as a data frame, so you can pull out that information as a data frame with timings.
Okay.
Not sure how to do that, but it's in the documentation. It's always I think you might be able to take a screenshot of this from within R. I'm not sure.
Okay. Okay.
Yeah.
Very interesting. Okay. Cool.
Other questions? Presumably there are Python equivalents to this folks use.
I was trying to think about that related to Python. Obviously there are some tools for dependency graphs and some other pieces, but I'm struggling to think of a package that really puts all that together to kind of situate in. I think for an example of when we were first talking about having this talk and everything else, I was just doing a little bit of search on Drake, and I was like, man, okay, seems like there's something really cool here, but there's something that I'm missing, big piece. And so kind of what you've described, tonight with all this setup, I could be wrong, obviously. I'm sure there's tons of stuff out there, but there's nothing that I can really remember listening to on a podcast or seeing in the community online about something quite like this, where you're not only able to get dependency graph type information, which is cool, but obviously make a workflow that constantly does it. Most time people I've seen, you're generally building that workflow for yourself, which runs to the haphazard reasons of why you want a package like this. I will say that rOpenSci just got started about 6 months ago as a sister effort to the great work that rOpenSci has done. And so I would say, like, Python community on some things has a lot of great work on some other things that R didn't necessarily focus on, or the tidyverse community or other people built on top of that did. But in terms of stuff like this, or obviously like the OpenSci kind of conversation piece, Python community, at least in my biased opinion of looking at it, and I use a lot of Python, I kind of see it almost as being like 2 years behind of like what some of the stuff that R is, or the rOpenSci's dedicated group of people have done. And obviously the nice thing about a lot of the great things about rOpenSci that I really love is that you can talk to most of those people on Twitter or on a GitHub message about certain things. So yeah, it would be really interesting to see something like this move forward. We have Flask and some other things that to do routing and other pieces, and to script it together into like an output. But we don't really, there's not really a full markdown equivalent. Our closest thing that we rely on a lot of is like Jupyter Notebooks and Jupyter Lab. And you can even build those to be parametric based on what you're trying to look at and use. But I would say there's some missing features for sure related to some of the workflows you can do here. And that's what I love about data science feel, and what we're kind of terming that as around, is that you can kind of use bits and pieces of different languages if you use that for whatever, it's ultimately just trying to get what you want to do, do it better or get something done. And so nice things you can kind of, this is another great, I think this has been a really great example of why you might want to use R for certain things, because you have this great workflow that you might have to do a little more work to replicate in a different language. So definitely really cool.
One thing I should mention about reproducibility also is I'm not doing something of like caching packages. So if a package that I'm relying on changes, right, then my workflow could still break, right? So if I'm using something to like pull something from a website or something, that can change. And there are ways in R to do that. So something called packrat, which can help you save like versions of packages. And that's the even better way of doing this. So you can still within the Drake framework, but that way you can have track of like, I want Geiger version 3.0312 or something, and I'll use that.
So I have a question about projects. When I look at the dependency graph here, this is a finished project. But in the process of doing it, often one goes off on blind alleys, or even things that work, but you decide not to put them in the final paper. But I don't want to lose track of those. So is there a way in the make plan to like hashtag something so that it's saved, but not run?
So, I mean, you can comment things out, right? So you can just do, boom, and it's commented out and won't run that part. Also, you can do, better plan, right? You can say, like, get rid of this line, get rid of this line, and then my make file, I can make, better plan. And so then I still have this older version, right? If you want to comment the whole thing out, you could. You don't have to, right? It will just run this better plan instead.
Okay, great. Thank you.
Other questions? Anything wasn't clear? I'm sure, not everything was clear, and that's normal, right? Especially when I present. But anything people think we don't want to look at again or something like that?
Is there a particular place you'd recommend that we start? And there's the whole book, and there's various things. Is one of those particularly helpful for someone just trying to get into this for the first time?
I found the book really helpful. I mean, it is a book, but it's not that long, right? It's not a 300-page dense manual. And so, I mean, the whole thing is, I'm not sure what the equivalent number of pages is, but it's not that bad to read through the relevant sections. And a lot of it is dedicated to examples, right? So for me, looking at a couple of the example files they have can be helpful. and then just going through the first maybe 4 chapters, and that's pretty much all you need to at first. And if you start getting into like these needs to do things in parallel or parallel branching or dynamic branching, read those chapters. And then there's also a chapter on high performance computing down here, which is handy. So we have a parallel backend. You can use that too.
Okay.
Brian, you mentioned you're writing an open book. What's the topic of the book?
Oh, comparative methods. So I'm teaching a class this semester, philomath.info, and it has a syllabus and also has a book online, and that book is being done in R Markdown. So you can go and look at the source code for the book and see, so every chapter is an R Markdown file. All right, so, so null hypothesis testing, so that, right? And then it can compile a book that people can then just go and read. So yeah, so that's, in that course, everything is available online for that course, which is handy. It has some videos associated with that, exercises associated with that. And the website for the course as well is made with R Markdown.
Awesome. Cool.
Yeah. Like once you have a hammer, you just keep hammering things out with it. I teach another course in macro evolution, but that course, it's also the lectures and things are available online. But the course is, all the slides and things like that. But it's a traditional course where it's lecture and discussion in class.
Cool. Well, speaking for myself, I'm looking to use this with the next kind of new project I do. It seems like a fairly easy lift to do, at least something sort of like that, the kind of simple use of Drake. And I could see it being super helpful. Almost every time I do an analysis, sorry,
That's okay.
it involves having to rerun things, which usually involves me having made some change at some point. And yeah, this just seems super helpful. Thank you.
Thank you.
Cool. All right. Well, if there are any other questions, I think this might be a good place to stop. So Brian, thanks again. This was a really great, both intro and like really good dive into like Drake, and I'm like chomping at the bit to like start using it because it seems now that I got at least a good start point, and then that book link that you sent as well. I'm like excited to see like how I could make my workflows even easier that I've overlooked. So yeah, it definitely sounds really cool. So with that, again, thanks Brian for giving this talk. Yeah, I really appreciate it. One other side note, we for KnoxData this past year, we were involved in creating the Knoxville City Hackathon. We're still in the process of kind of organizing this year's hackathon. Obviously, we're juggling around, but right now we're targeting August to be where we would want to do anyway. And so look forward to more info about that in the coming months. But otherwise, thanks again, Brian. So with that, thanks again, everybody, for coming. And I hope you guys got a lot out of it. If you have any follow-up questions, you can reach out to us and we can forward along to Brian, or Brian's links on Twitter or anything else. You can catch him there. So thanks again, everybody.
Thank you, everyone.
Much appreciated.